All right, continuing on with this whole approximating cube roots and square roots. Yesterday was all about approximating square roots. Today we're going to approximate cube roots. Okay, so again, we got a little warm up right here. So we're going to run through and we're going to write down all these perfect cubes here. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Again, these are things that hopefully you've got memorized, especially to write here 125. And then 6 cubed, do you remember what that one is? It's 216. That was past the point where you had to have it memorized, but if you've got that memorized, it does come up fairly often. Okay, next one. Is there a number that you can square to get -4? Now, if you'll recall, we did talk about this before. Can you square a number and get a negative? So the answer to that is no. Now, is there a number that you can cube to get -8? Well, when you're cubing, remember, instead of having two factors, two things that are multiplied together here, so two signs, two negatives or two positives, which would always make a positive, we've got 3 when we're cubing something. So the answer on this one is yes, because if we took -2 and we cubed it, that would be -2 times -2 times -2. 3 negatives make a negative, and 2 times 2 times 2 is 8. So that would work just fine right there. Now, these right here, hopefully you've got that list memorized and you understand the relationship between perfect cubes and perfect cube roots and different things like that. So the cube root of 1 is 1, cube root of 8 is 2. It's kind of going through this list backwards. So the cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5, cube root of 216 is 6, this would be 7, this is 8. Now, I skipped 9, didn't quite have enough room to put it on here, but the cube root of 100, remember we've got these 3 zeros there, that means it would be 3 tens, so that means the cube root of 1000 would be 10. Okay, now for today's assignment, you've either got to be able to recognize one of these perfect cubes that are listed up here, and maybe even 9 cubed, which is 729, so that you can find its cube root very quickly. Okay, or you're going to need to be able to figure out what two numbers it would be between. So what two perfect cubes it would be between, kind of like we did yesterday with the perfect squares. So once we know what two integers that cube root is between, then that's going to serve as our estimate. We're going to figure out which integer it's closer to, and that's going to serve as our rough estimate or approximation of the answer. Okay, so of the actual answer. All right, let's take a look here. It says find the value of each cube root, and these are very similar to your assignment. If it's not an integer, determine what two numbers it is between, and then give your best estimate to the tens place. So all you need to do is give an estimate. We don't have to get really carried away like we did yesterday, getting really, really close. So when you're done, you can use your calculator to see how close your answer is. Now, I will warn you, if all of your answers are perfect estimates, you're doing something wrong. Okay, this is about giving a good mental estimate without grabbing a calculator. We do have access to a calculator, but I do just want you to kind of confirm your answer and see how close you are. So let's take a look at this one right here. I'm hoping that you recognize that one right there because we just did this one up above. Okay, 125 is a perfect cube, and the fact that it's negative means the answer is going to be negative, and 125 is a perfect cube of 5. So there's our answer right there. So on that one, there's no estimate. That is the exact answer. Now the next one is the cube root of 121. Now I put this number on here for a reason. When you see 121, a lot of people think, oh gosh, the answer is 11. On this one, it's not 11 because this is a perfect square, not a perfect cube. So let's stop and think about this. If we were going to put that between two perfect cubes, that's why I did this one right here, 125 would be on the larger side of that. And then let's think back on our list. This would be 5 cubed. It's going to be the cube root of 64. Okay, so this would be a 4, this would be a 5. So the cube root of 64 is 4, the cube root of 125 is 5. Now, those are the two integers that it's got to be between, but which one do you think it's closer to? Well, this is just 121, this is 125, so it's probably closer to 5. Now, This is not a good estimate. Don't just say 4.5, circle it, and say, oh, I'm done, I gave an estimate. Okay, I want you to give a little bit more thought than that. So if it's closer to 125, let's take a guess that's closer to 125. Sorry, closer to 5. So let's say 4.9. Now I'm going to go ahead and circle that, and I'm going to use the calculator, and I'm just going to check and see. Now the nice thing about this is it just says take a guess. You don't have to be perfect about this. So what we're going to do right here is I'm just going to take 4.9 and I'm going to cube it. Now to cube something, we do this. We hit this caret key. This is the exponent key. Notice that it hops up right there. And I'm going to put a 3 there, and then I'm going to hop down. Not that you have to. And I'm going to hit enter, and we get 117. So pretty close, not quite there. It's actually a little bit more than 4.9, maybe 4.95 or something like that. But all we need to do is give an estimate to the tenths place. Okay? So give your best estimate to the tenths place. So 4.9 would be totally okay. All right, let's take a look at this next one right here, the cube root of 60. That is not 64, so that's not going to work. We're going to have to estimate here. So let's see what we get here. This would be the cube root of 64. That would be a little bit on the big side. And then on the low side, that's going to be the cube root of, if you need to look at that list up above, 27. Okay, so the answer here is 4. The answer here is 3. This is going to be between here. And again, we're going to take a guess that it's really close to the cube root of 64. So let's say 3.9. Again, we wouldn't say 3.1. That would be crazy. That is between the two of those. But let's just check this out. Watch what happens if we did do 3.1. Whoops. If we did do 3.1, we would get something that is barely bigger than 27. Okay, not even close. So let's do 3.9 and let's cube that. Again, that caret key, that exponent key is above the divide there. And we get 59. That's pretty darn close. So pretty darn good estimate right there. Okay, cube root of 300. Now that's getting up on that list. You may have to look back if you don't have these memorized. That's going to be between 216 and, let's see, what was that? Well, this is 6. So that cube root is a perfect, 216 is a perfect cube of 6. So the cube root of 216 is 6. The other one, if you take a look at your list, is 343. And that is going to be the next integer in line. That's going to be a 7. Probably closer to the 343, but maybe a little bit more in the middle. Let's take a guess of about 3.6. Now, as long as it's reasonably close, we're going to be just fine with that. So let's do 3.6, raise that to the third power, hit enter. I'm sorry, 6.6. Gosh, I knew something was wrong there. 6.6, that's what we're after. Okay, 6.6. And then we're going to raise that to the third power. So let's see how it turns out there. Yeah, 287, not too bad. Let's just, for the heck of it, say your neighbor guessed 6.7. We're going to raise that to the third power. Holy cow, that's almost right on the money. So 6.6, 6.7, either one of those, as long as we give it a good estimate, then we're just fine. Okay, so let's take a look at, let's see, negative 53. We got to think about that one right there. Notice, this is kind of like the one up above. That would be the square root of negative, I'm going to write it this way. Because a number line, remember, if 0 is here and negative 5 is here and negative 10 is here, we put the bigger one on the biggest negative on the smaller side right here. So we're going to do negative 64 here, and we're going to do cube root of negative 27 here. Now, if you happen to mix them up or something like that, that would be totally okay. I'd be fine with that. But let's check and see. This would be negative 4, and this would be negative 3. So this is going to be somewhere in between there. You know, it's kind of close to that. So maybe we say negative closer to 4 than it is to 3. It's not 4 point something, it's going to be 3 point something. And let's say on this one we say negative 3.7. And again, we'll grab the calculator and we'll just check this. So we've got negative 3.7. And we're going to cube this. Now, I do want to mention right here, this is a horrible way to put this in. Okay, so please don't do that. What that's going to do is it's going to cube the 3.7 but not the negative. So the proper way to do this is to put this in parentheses. So we're going to do negative 3.7. we're going to close the parentheses, and then we're going to raise it to the third power. So we get negative 50.6. Yeah, good enough. That's going to be just fine right there. Okay, before we pick one from the assignment, I'm going to take a look at this one right here. This is the brain challenge. I'm going to pause for just a second, and you can take a minute and see if you can figure that one out. You might want to notice that there are 3 zeros and that the number 8 is a perfect cube. That's a little hint there. Okay, on this little brain challenge one, there's not really any rounding that's going to be required if you spot this. 8 would have a 2 in it. And remember, if there's a negative inside the radical, the cube root, the answer is going to be negative. And then if you notice we've got 3 zeros, that means there's going to be a 10 on the outside. So that let's just take a guess that it's 20. And I'm going to grab the calculator, and we're going to do, again, parentheses, negative 20, close the parentheses, and then we're going to cube that. We end up with negative 8,000. So if you recognize those perfect cubes like 1,000 and 8 and 64 and 27 and 125 and things like that, it can make things like this a heck of a lot easier. So I'm not going to give you anything that difficult on the assignment. So here's what we're going to do. We're going to take a look at number 6. So I'm going to flip over to this page right here, and we're going to take a look at number 6. Now again, notice the instructions on 3.5b. It says find the value of each cube root. If it is not an integer, determine what 2 numbers it's between, and then give your best estimate to the tens place. So here's what we're going to do. On this problem right here, I'm going to make this a little bit bigger, and we're going to come up with an estimate. Now, think about perfect cubes. Perfect cubes would be numbers like 1 and 8 and 27 and 64 and 125. There's only 5 that I asked you to memorize. Well, these are going to be the ones that we use. So this is going to be between the cube root of 1 and the cube root of 8. So it's going to be between a 1 and, let's see, the cube root of 8 is 2. Now, which one is it closer to? Gosh, it's a little bit closer to the 1. So let's maybe take a guess of about 1.3 or something like that. And then let's just try our answer and see how close we are. Hopefully we're in pretty good shape. So let's do 1.3, and then we're going to raise that to the third, and we end up with 2.19. Just for the heck of it, let's say we guessed 1.4, and then we raise that to the third. 2.7. Yeah, so not too bad. Either one of those would be fine. Let's see how far we can press this. Is it 1.5? Nope, that's a little bit too big. So it's going to be in between 1.4 and 1.5. But again, it doesn't have to be perfect. It just has to be a good estimate. And 1.3 is a perfectly good estimate. This is the type of work that I'd like to see on this assignment. Again, you're writing down your thinking process here. What perfect cubes is it between? What are each one of those perfect cube roots? And then you're kind of showing, I'm not just going to guess that it's 1.5. I'm going to say, this is a little bit closer to 1, so I'm going to guess closer to 1 than it is to 2. All right, good luck on the assignment. I realize this is challenging, kind of new ways to think about stuff and lots of new numbers, but it's well worth it because you are going to continue to see these on a regular basis this year and in the future.